There's this whole world of invisible engineering that keeps us safe every single day. We are surrounded by incredibly powerful machines, but we just go about our lives. And that's all thanks to a critical and honestly often overlooked field, machine guarding. So let's dive into this hidden world of safety engineering. Right off the bat, you need to understand why this is so important. The stakes are just unbelievably high. I mean, look at this list of potential injuries. It's horrifying. These aren't just risks on a spreadsheet. These are real, life-changing events that good engineering is designed to stop from ever happening. So that's the big question, right? How do we stop this from happening? How do we design safety into systems that are, by their very nature, pretty dangerous? Well, the answer isn't just one thing. It's a whole approach, and it starts with really understanding where the danger comes from in the first place. Yeah, before we can even begin to talk about solutions, we have to get a handle on the dangers themselves. Accidents don't just happen out of the blue. They almost always come from a handful of predictable, and that means preventable situations. When you look at these common causes, you see it's a mix of human decisions and mechanical issues. Something as simple as reaching in to clear a jam, it feels like a quick shortcut, but it's a classic recipe for disaster. Same with not using lockout/tagout. That's the procedure for making absolutely sure a machine has no power before you work on it. It really shows you that for a system to be safe, the machine's design and the operator's actions have to be perfectly in sync. Okay, so if those are the causes, where on the actual machine do these hazards live? The thing is, it's not the entire machine that's dangerous. It's specific zones where all that energy and motion is focused. Let's break down the anatomy of a hazard. So engineers have basically identified 4 main danger zones. The most obvious one is the points of operation. That's where the business happens, the cutting, the shaping, whatever it is. Then you've got the power transmission parts, all the belts, gears, and chains that make the thing go, and of course, any other moving parts. But then there's this last one, something called an in-running nip point, which is especially nasty. So what in the world is an in-running nip point? Okay, picture a belt moving over a pulley, or 2 big rollers spinning towards each other. That spot right where they meet creates this intense pinch point that can grab a loose sleeve, a piece of jewelry, or your hand and just pull you right into the machine. They are without a doubt one of the sneakiest and most dangerous hazards out there. All right, now that we know the problem inside and out, let's talk about the cure. But you can't just go slapping a piece of plastic on a machine and call it a day. No, engineers follow a really strict set of rules. Any safeguard, whether it's super simple or incredibly complex, has to meet 6 key requirements to be considered effective. So a good guard has to prevent contact, that's a given, and it has to be secure, so you can't just pop it off. But here's what's brilliant. It can't create any new hazards, like having its own sharp edge. And, this is huge, it can't interfere with the job. Because let's be real, if a safety device makes the work impossible, people are going to find a way around it. Safety and efficiency have to go hand in hand. With those rules as our guide, engineers have come up with this incredible toolkit of solutions. And we're not just talking about simple barriers here. A lot of these are really clever systems that are actively working to protect people. Let's look at a couple of the big categories. You can basically split these solutions into 2 big groups. On one side, you have guards. Think of these as permanent physical barriers, like a fence or a shield. On the other side, you have devices. These are active systems. They don't just block you, they actually sense what you're doing and react to keep you safe. The interlocked guard is the perfect example of a smart barrier. The best analogy is your microwave oven. The second you open that door, everything stops, right? The light goes off, the cooking stops. That's an interlock. It physically connects the guard to the machine's power, making it literally impossible to run the machine in an unsafe way. It's so simple, but so incredibly effective. This right here shows you just how much safety has evolved. The classic 2-hand control is a great device. You have to press 2 buttons at the same time to make the machine go, which guarantees your hands are nowhere near the danger zone. But look at the ergonomic version. It's even smarter. It doesn't need that constant, tiring pressure, but it does require you to hit both controls within a tenth of a second of each other. It's safer and it's easier on the user. It shows that great safety design thinks about the human too. And now we're getting into some seriously cool tech. A light curtain is pretty much what it sounds like, an invisible shield. It projects this grid of infrared light beams across an opening, and if your hand, or anything really, breaks that plane of light, the machine shuts down instantly. It's an amazing non-contact solution that gives you easy access when you need it, but provides a massive safety net. But here's the thing.
all of this incredible technology, from smart barriers to invisible shields, it's still only one piece of the puzzle. A perfectly engineered guard is totally useless without the human element. Real, lasting safety is a culture. It's a shared responsibility where absolutely everyone has a part to play. It's like a chain of responsibility, you see. Management has to provide the right equipment with the right guards. Supervisors have to make sure their teams are trained and that those guards are actually working. And the employees on the floor have that critical job of never messing with the guards and speaking up the second something looks wrong. If any single link in that chain breaks, the whole system can fall apart.
And that's exactly why training is so non-negotiable. It's not enough to just say, hey, don't touch that. People need to understand the specific danger of their machine, how that guard is protecting them, and exactly what they need to do if that protection is ever missing or damaged. Knowledge is the final and maybe the most important layer of defense. And really, it all comes back to this one simple idea. This is the golden rule, the fundamental principle that drives everything we've talked about. If a machine part, function, or process can cause an injury, it must be safeguarded. No ifs, ands, or buts. That is the core philosophy that keeps people safe in our modern, mechanized world. So as we wrap this up, I want to leave you with a thought. The next time you get in an elevator, use a blender, or even just drive your car, take a second to think about all that silent, invisible engineering that's humming away in the background. What unseen safety systems, what clever interlocks and hidden guards are protecting you right now?